Alright, so I believe this is recording. Let's take a look at problem number 6. Now, I guess the first time a student looks at a problem like number 6, it could be tricky. The part that will be tricky is to convince you that if we zoom in tight enough to the origin, that there's no portion of this graph right here that is constant. It looks to me, let's assume for a minute that we knew that the equation of this function was x cubed. So we know that as you increase x, as x gets larger, then when you cube it, the output is also going to get larger. So many times when you know both the equation and the graph, you'll kind of work with it simultaneously to get your answer. But here we only have the graph to go off of. As we enter the graph from the left, we hit an arrow, which we know that tells us two pieces of information: that the x coordinates are going to negative infinity as the y coordinates are going to negative infinity. As we move to the right and exit the graph on the right, we hit an arrow, and that tells us that as x is going to positive infinity, y is also going to positive infinity. So I always come in and work on the graphs from left to right, because as you move left to right, the values of x increase. And as x is increasing here, I'm also going up, so y is increasing. Now y continues to increase, and then it starts increasing really slow, but it's still increasing slightly, and it goes through the origin, and it's still, as x increases, y is increasing slightly, and it's going. Then it starts the rate of increase increases, and we're definitely increasing there. So this function is increasing over the entire domain from negative infinity to positive infinity. It's never decreasing, and it is never constant. The graph does not have symmetry with respect to the y-axis, so it's not even. It's going through the origin, and when you rotate it 180 degrees, you get the same picture. Okay, so this is an odd function. The algebraic definition, you have to be careful that when you apply an algebraic definition, it has to be true for all points on the graph, not just points that are convenient. But if I use this point just kind of as an example, that the graph is passing through the point 1, 1, the opposite of 1 is negative 1, and the opposite of the y-coordinate 1 is also negative 1. So if for all points, if xy is on the graph and the opposite of x and the opposite of y are also on the graph, then it's an odd function. Alright, hope that helps.